Hey everyone, and welcome to video lecture 2.3 on vector components. So last time we talked about adding vectors geometrically, which can sometimes be pretty tedious. So there's another way that involves some algebra and the coordinate system. And vectors can be broken down into components, which is basically a projection of the vector on an axis. So like the x component is the projection along the x-axis and the y component would be along the y-axis. We can find the components of a vector through this process called resolving the vector. And to do this, we just draw perpendicular lines from the two ends of a vector to the axis as shown here. And in general, a vector has three components, the x, y, and the z components, although here the z component of vector A is 0. Also important to note is that if you move a vector without changing its direction, its component will stay the same because, as you remember, vectors aren't anchored to any specific point in general, as long as the direction and magnitude are the same. Okay, so geometrically, we can find the components of a vector, say A, as we note that its components form a right triangle. And using some trigonometry, we note that the x component is A cos theta, where theta is the angle that vector A makes with the positive direction of the x-axis. And similarly, the y component is A sine theta. Now, it's important to understand where we're measuring theta off of because sine and cosine can switch based on that, so it just depends on the structure of your right triangle and how you design your trig functions. Once a vector has been resolved, we can use the components in place of the vector, and we can easily switch between the component notation and magnitude angle notation using a set of relationships shown here, where the magnitude of A is found as a square root of the squares of the components. Recall the Pythagorean theorem, and the angle can be found as arctan of AY over AX. In the general case, three-dimensional case, we would need a magnitude and two angles, say A, theta, and phi, or three components, AX, AY, and AZ to specify a vector. But we'll be mostly working with 2D vectors for the time being. All right, that's it for today. Thank you so much for tuning in, and we hope you've learned something new.